This lecture video is about inverse functions. So today we're going to look at how to find inverse functions for different types of functions. Last time we looked at what one-to-one functions were, and this is why we needed to know whether a function was one-to-one or not, is because in order for a function to have an inverse, it needs to be one-to-one. And so it needs to pass that horizontal line test that we looked at. Um, so, um, so first you want to make sure that it's one. The reason that it needs to be one-to-one is because of what an inverse function does. So what an inverse function does is it takes you from the y value and brings you back to x. So this is what an inverse function does. The notation that we use for an inverse function is an f. It's f of x, except for it's like it's being raised to the negative first power, but this really means that it's the inverse function. So that's what this notation means when you have a little negative 1 there in the exponent, is that this is really an inverse function. So this is the notation for an inverse function. So what an inverse function does is it takes you from the y value of your function back to the x value of the function. The function takes you from some x value over to some y value. So basically an inverse function undoes a function. And that's why it's so important for it to pass the horizontal line test. So if you have 2 points, one might be, we'll put numbers in there, say 1, 2, and this other point might be the point 3, 2. And so because the inverse function is starting with this y value, this 2, and trying to bring you back to the x, well, if you have these 2 points on a graph or that are part of a function, then I don't know whether this 2 should go back to the 3 or whether the 2 should go back to the 1, and that's why you can't have that situation when a function has an inverse. So the steps for finding an inverse, the first thing that you're going to do is instead of writing the f of x that we use for a function, we're going to replace that with a y. And then you're going to swap out your x's and your y's. So wherever you have a y, you're going to write an x. Wherever you have an x, you're going to write a y. Then you're going to solve this new equation for y, and then whatever you get will be your inverse function. And so you're going to replace the y with f inverse of x. So here we have a function a, and it's a list of xy coordinates. So first of all, the x values are all different, the y values are all different, so it is a function and it does have an inverse, and so we can go ahead and find that inverse. And so again, what happens with an inverse function is it's going to start with this 2, and its outputs, the input's going to be 2, and the output's going to be 1, and so our x value is going to be 2, and our y value is going to be 1. So that's what an inverse function does. It just flip-flops these points. So the next point would be the point 3, negative 1, and 4, negative 3. And so to write the inverse of a set A like this, you would just write A with a raised to the negative first power. But it's not really being raised to the negative first power, it's just our notation for an inverse. So our next example, we have the point 6, 2, 9, 9, 1, 4, and negative 1, 5. So first of all, we have 6, 9, 1, and negative 1, so all the x's are different. 2, 9, 4, and 5, so all of the y values are different. So it's both a function and it has an inverse. And it's 1-to-1, so it has an inverse. So again, we just flip-flop these points. So instead of 6, 2, it's going to be 2, 6. Instead of 9, 9, well, 9, 9 stays the same when you flop it. And then 1, 4 will become 4, 1. And negative 1, 5 will become 5, negative 1. And so there's our inverse function for b there. These next examples are all equations, and so we need to use those steps that we had before. And so the first step is just to write this with a y instead of f of x. So y equals 2x plus 3. And then the second step was to replace the y with an x and replace the x with a y. So you're just going to swap the x's and the y's. So step 2 means write this as x equals 2y plus 3. And now we want to solve this for y. So the first step in solving this equation for y would be to subtract the 3 from both sides. So I would have 2y is equal to x minus 3, and then divide both sides by 2. And so we get y is equal to x minus 3 over 2. And then the fourth step was just to replace the y with the inverse function notation. F inverse is equal to x minus 3 over 2. And you can just leave it written like that, or you could also write this function f inverse of x is equal to 1/2 x minus 3/2. So either way, either of these two would be acceptable for that. Okay, our next example here, f of x is equal to 4x minus 5 over 3. So again, step 1 is just to write this as y equals 4x minus 5 over 3. Step 2 is to swap the x's and the y's. So this would be x equals 4y minus 5 over 3. And the third step is to solve this for y. So the first thing that I would need to do is multiply by 3 on both sides so that these 3's will cancel. That gives me 4y minus 5 is equal to 3x. Then we need to add the 5. That gives me 4y equals 3x plus 5. And the last step is to divide by 4. So we have y is equal to 3x plus 5 over 4. And then step 4 was just to use the inverse notation to write that. And again, same thing as with the last equation. You can keep it in this form, 3x plus 5 over 4. That's totally fine. Or you could write it in this way. F inverse of x is equal to 3/4 x. Just divide each of the terms in the numerator by 4 plus 5/4. So either way is fine. Okay, back up to example C. So this time we have f of x equals the cubed root of x plus 9. And so we want to replace the f of x with y. And then we're going to switch the x's and y's, so that's going to be x equals the cubed root of y plus 9. And then we want to solve this for y. So the way that we're going to undo a cubed root is we're going to cube both sides. So this cube and this cubed root will cancel each other out. And so we'll have x cubed equals y plus 9, and then subtract 9 from both sides. This gives us y equals x cubed minus 9, and then replace the y with our inverse notation. F inverse of x is equal to x cubed minus 9. Okay, and on this example and the last example for these finding the inverses, I just wanted to show you how you tell whether something is an inverse of one another or not. And so the way that you would do that is with the Fogg and Goff stuff that we learned before. So you want to put the inverse function into the function. And so this inverse function, remember, is taking in the function's y value, or taking in the function's y value and getting you back to x. So so when you do this computation, you should end up with x. And the same thing should happen if you do this the other way around. If you plug the function into the inverse function, you should also end up with x. So both of these should give you x when you do it. And so let's try this. So we want to find f of f inverse. So when I plug the inverse function into the function was the cubed root of x and then plus 9. And so I'm going to replace the x here with my inverse function, which is x cubed minus 9. Okay, so we have negative 9 and positive 9, so that's 0. And so we get x cubed, and it's the cubed root of that. So this is all we're going to have left underneath this cubed root. And this cubed root cancel each other out, so we get x. Okay, likewise, if we compute this the other way around, this time I'm going to plug the function into my inverse. My function was the cubed root of x plus 9. Get my little cubed in there. And my inverse function was x cubed minus 9. And inside the parentheses here, I'm going to put my, my function f. So this cubed root of x plus 9. Okay, so when I do this the other way around, now this cubed root and this cubing are going to cancel each other out. So I'll be left with this x plus 9. And then we have minus 9 on the outside here. And positive 9 and negative 9 gives you 0, so we're left with x. Okay, so both ways that we did this, we ended up with x. And so because we got x both ways, these are inverses of one another. Okay. So now let's find the inverse of our last function here. Our last function is f of x equals 6 over x, or 7 minus x. And so we want to find the inverse of this. First step is to rewrite this so that we have y equals 6 over 7 minus x. And then swap out the x's and the y's. So instead of y, we're going to write x. And it's equal to 6 over 7 minus, and instead of x, we're going to write a y. And then we need to solve this for y. So to do that, we need to multiply by 7 minus y on both sides. So we have x times 7 minus y on the left. And these 7 minus y's will cancel, leaving us with 6. So I need to distribute this x. That gives me 7x minus xy. And we're trying to get this y alone, so now I'm going to subtract 7x from both sides. That gives me a negative xy equals 6 minus 7x. And the last step is to divide by negative x. So, and I'm fine with you just leaving it like this. You could do some things to simplify this a little bit. You could write this with a negative sign out front. Or you could distribute this negative sign then into the numerator here, and that would give you a positive 7x minus 6 over x. You could also divide each term by x, giving you 7 minus 6 over x. All of these would be acceptable answers as far as I'm concerned. So there's a lot of different variation as to how this can look in its final form. The form that I like the best is this one right here, 7x minus 6 over x. So that's the one that I'm going to call my inverse function, because that's the form I like the best. And I'm also going to show you that these two are in fact inverses of one another by plugging them into each other, just like we did for the last example. So first I want to find f of f inverse. So my function f is 6 divided by 7 minus x. So I'm leaving a parenthesis there for x, because what I'm going to put in that parenthesis now is my inverse function, which is this 7x minus 6 over x. Alright, so we need to simplify this denominator now. So I want to distribute this negative sign. So I have 6 on the top, and then 7, and I'm going to actually distribute this negative sign to the 7 and to the negative 6. So I'll have negative 7x plus 6 over x. So you really have, whoops, write this a little bit different. So you'll have 7 plus this expression. So we need to simplify this. I need to get rid of this little fraction here, and the way that I would get rid of this little fraction is to multiply by x. But whatever you do to your denominator, you have to do to the numerator. So I'm going to multiply this whole denominator by x, and also multiply my numerator by x. So I have to distribute this x, so I have to multiply it to this fraction, and I have to multiply it to this 7. So I have 6x on the top, and then on the bottom I have 7x. And these x's then will cancel when I multiply it to this term. So I have minus 7x and plus 6x. Oops, no x there, sorry. Because these x's are canceling. So now 7x minus 7x cancels and is 0, and then 6x divided by 6 is x. So we do in fact get x when we plug the inverse back into the function. Okay, now to do this the other way around, so I want to start with the inverse function, and I'm going to plug into the inverse function the function f. So my inverse function was 7 times x minus 6 divided by x, and what I'm putting in for x is my function, which was 6 divided by 7 minus x. Okay, so here we have 7 times this fraction, so we can go ahead and take care of that. I'm going to switch back to my black pen. Okay, so that would just give us 42 over 7 minus x minus 6 on the top, and then 6 over 7 minus x on the bottom. And so now we have this complex fraction, and remember the way that we simplify these complex fractions is we multiply both the numerator and the denominator by the common denominator, which is 7 minus x in this case. So we have two little fractions in the big fraction. This one, 42 over 7 minus x, and 6 over 7 minus x. So when we multiply this, we have to remember to distribute it. So when I multiply it to the 42 over 7 minus x, the 7 minus x in the denominator will cancel, leaving me with 42. And then minus 6 times 7 minus x. And then in the denominator, these cancel, leaving me with 6. So now we can distribute this 6, giving me 42 minus 42 plus 6x, and then divided by 6x. And so again, 42 minus 42 is 0, and 6, oops, sorry, there's just a 6 in the denominator. 6x divided by 6 is x. So you do in fact get an x again. Okay. Alright, so a couple more examples here, and that's finding the inverse of a function and then graphing the inverse and the function on the same axes. And so here we just have some points, and so the inverse is just going to be these points flip-flopped. So negative 5, 2 will become the point 2, negative 5. I'm going to move this down away from, there we go. And then the point negative 2, 5 becomes a point 5, negative 2. and the point -1, 0 becomes a point 0, -1. Okay, so we just flip-flop all of our points. I am going to graph our function in black. And so we have -5, 2. And we have -2, 5. And we have -1, 0. And then in red, I'm going to graph our inverse function, which are these 3 points. So we have 2, -5. And we have 5, -2. And we have 0, -1. And then in blue, I'm going to graph the line y equals x. So the line y equals x is, and I'm going to do it as a dashed line, but it cuts both the first and the third quadrants right in half. And so what you'll notice here is that this black dot, if you reflect it across the blue dot or blue line, becomes this red dot. And same with this point, when you reflect it across the blue line, becomes this point here. And same with the point -2, 5 reflected across the line y equals x will be the point 5, -2. So the inverse function and the function are mirror images across this line y equals x. Our next one is f of x equals 3x plus 5. So first I'm going to find the inverse. So the first thing that we do, and you can eliminate that first step really, you can just swap out the x's and the y's and write this as x equals, oops, I'm going to change back to, I'll change to red since we're doing the inverse function in red. So you can just write this right away as x equals 3y plus 5. And then solve this for y will give you your inverse function. So subtract 5. That gives me x minus 5 equals 3y, and then divide by 3. So our inverse function is x minus 5 over 3, which is the same as 1/3 x minus 5/3. So we want to graph both of these on the same set of axes. So this is a line. It has a slope of 3 and a y-intercept of 5. So it's crossing the y-axis at 5. So that's 0.05. And then it has a slope of 3, which you would think of as 3 over 1. And so the top number is your rise, bottom number is your run. And so we could go up 3 and to the right 1 to get another point. And we could go down 3 and to the left 1. And so this is the point 1, 8, and this is the point -1, 2. Okay, so here is our function. Now, I don't draw very straight lines, but you get the point. And then we want to also graph this inverse function. Well, we have 3 points already on the function, so we could just flip-flop those to get the points on our inverse function. 1, 8 would become the point 81. 0, 5 would become the point 50. And -1, 2 would become the 2.2, -1. And of course I drew this, so they're not perfect, but these should all intersect in one spot right here. And they're pretty close, but not exact. So you could also graph this just like we did the other one. It has a y-intercept of -5/3. That would be -1 2/3. So that's about where it's crossing the y-axis here. And then you could use the slope to find a couple other points. But like I said, you can just flip-flop the points from your function as well. Oh, and I didn't label my points. Make sure that you're labeling points on your graphs. So this is the point 50. and 2, negative 1, and then, oh, here's the other point, 8, 1. Okay. And then our last one, we have f of x equals x cubed minus 2. So we know a little bit about this. The only thing that we really have learned about this so far is that this negative 2, you should have some idea of what this negative 2 is doing to the graph. From transformations, it's shifting the graph down 2 units. So I'm going to plot a couple of points to get the graph of this function. So I'm going to plug negative 2, negative 1, 0, 1, and 2 into the function. So negative 2 cubed is negative 8, minus 2 gives us negative 10. Negative 1 cubed is negative 1, and then minus 2 gives us negative 3. 0 cubed is 0, so we get minus 2. 1 cubed is 1, and 1 minus 2 gives us negative 1. And 2 cubed is 8, minus 2 gives us 6. So I'm not going to plot the first point because it's off my graph. We have negative 1, negative 3. And we have 0, negative 2. And we have 1, negative 1. And we have the point 2, 6. So it kind of looks like it's forming a line here, but then all of a sudden it goes way up. So what this graph really looks like is it looks like half of a parabola opening up on this side and half of a parabola opening down on this side. And we also had this point 2, negative 10 that we didn't put on here because the point was down here off my graph. Okay. So that's the general shape of this graph. This is the point 2, 6, and this is the point negative 1, or whoops, sorry, 1, negative 1. And we have that point labeled, and 0, negative 2. So now, again, to graph the inverse function, we can just flip-flop these points. We don't even need to figure out what the inverse is. We can just flip-flop the points and get the graph right away. It's going to have the point 6, 2. And it will have the point negative 1, 1. And it'll have the point negative 2, 0. And it'll have the point negative 3, negative 1. And also it would have the point negative 2, negative 10, or negative 10, negative 2, sorry. So way over here and down by 2. So it also has this point way out here. So we can connect these dots to make our graph. And in blue, draw the line y equals x, which cuts the first and third quadrants right in half. And so you see how they're mirror images of one another. So now let's go back and find the inverse of this function. So again, this is going to become x, and this is going to be y. So we're going to have x equals y cubed minus 2, and we want to solve this for y. So add 2 to both sides. We get y cubed equals x plus 2. And then to uncube something, we would take the cubed root on both sides. So our inverse function is the cubed root of x minus 2. Okay, and that finishes up our lecture on finding inverse functions. Let me know if you have any questions. Thanks.